Dear students, until yesterday we have completed quadratic expressions. Until level 4 we have completed. To finish the chapter including IP and objective until level 4, approximately advanced level, I have taken 20 days. Now today I am going to start the new chapter IPE. The chapter name is Theory of Equations, that is Maths 2A only. Theory of Equations. According to IP weightage 2 plus 7, this is 9 marks weightage IPE. M set only 1 bit. M set only 1 bit. There is no main bit from this chapter. Main bit 0. There, of course, there is not advanced bit. Theory of Equations chapter. Only M set, only 1 bit will be reading. Now, let us write the definition which is required for this chapter. Polynomial equation. Polynomial equation. Maybe I said same definition in quadratic expression chapter only. Quadratic expression chapter also I said. An equation which is in the form of f of x is equal to a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus so on ar x power n minus r plus so on an a0 a1 a2 a3 so on until an is equal to 0 is called as a polynomial equation. A polynomial equation of degree n. Here a naught not equal to 0 and a1 a2 so on may be real or complex numbers. A naught not equal to 0. A naught is called as leading coefficient. Leading. So x power n is the greatest degree. The coefficient of highest degree is called as leading coefficient. A naught is called as leading coefficient. If is equal to 0 is not there, then we can understood that expression as an nth degree polynomial. That's all. If is equal to 0 is there, it is polynomial equation. Now we can write a polynomial equation. An nth degree polynomial. An nth degree polynomial equation contains n roots. It can be defined as f of x is equal to depends upon this, whatever the equation I said, depends upon x minus alpha 1 into x minus alpha 2 into x minus alpha 3 so on x minus alpha n regarding quadratic expression concept. F of x is equal to ax square plus bx plus c we can understand as a into x minus alpha and x minus beta for two roots. If it is cubic equation, x cube plus bx square plus qx plus r can be written as x minus alpha and x minus beta and x minus gamma. If it is biquadratic equation, we can write x power 4 plus ax cube plus bx cube plus cx plus d can be written as x minus alpha and x minus beta and x minus gamma and x minus delta like that. If it is nth degree polynomial, we can write this one as x f of x equal to x minus alpha 1 and x minus alpha 2 so on until x minus alpha n. So we can understand that polynomial equation contains n roots. Depends upon this one. We can understand relation between coefficient and roots. Relation between coefficients, comma roots. Relation between coefficients, comma roots of a polynomial equation. A polynomial equation. If f of x is equal to general notation. If f of x is equal to x power n. Generally, the polynomial contains if a naught. We should standardize the equation with dividing with a naught. Then it becomes a1 by m x power n. Leading quotient should be 1. Of course, there is no need to put a rule. A leading quotient is 1. There is no need to put a rule. If we write in that form, then we can understand x power n plus here I am writing p1 into x power n minus 1. So you can understand this one as a naught. There is no a naught. So f of x is equal to, I am going to discuss it to the point is that x power n plus a1 by a naught into x power n minus 1. In the similar way, a2 by a naught into x power n minus 2 plus 1 at last an by a naught. That's all. So what is the point I am going to discuss with you? That remember a quadratic equation formula ax square plus bx plus c. Sum of roots formula minus b by a. Ax square plus bx plus c is equal to 0. Sum of roots minus b by n, product of roots c by a. If you are able to understand that if you divide the quadratic equation with a, so leading quotient is 1, then you can understand x square plus b by a plus c by a equal to 0. Then directly you can say that sum of roots alpha plus beta is equal to minus b by a and product of roots alpha beta is equal to c by a. There is no question of minus b by a by 1 and c by a by 1. In the similar way, whatever the quotient we have divided the a1 by a0 we are thinking as p1 and a1 by a2 by a0 we are thinking as p2. So x power n plus p1 x power n minus 1 plus p2 x power n minus 2 plus p3 x power n minus 3 plus so on until pn. So on pn. I am waiting. Now you remember the formula, students. Alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. So what is going on there? Alpha plus beta means only two roots we are having for the quadratic equation. So for two roots, sum of roots we are getting minus, and next for it is plus, next it is minus, next it is plus. Like that, the process will be alternate while calculating the roots. Now we can understand that the notation is S1. S1 means sum of roots taken at a time. Sum of roots taken at a time. S1 notation is sum of roots taken at a time. That means alpha 1 plus alpha 2 plus alpha 3 plus so on alpha n. Alpha 1 plus alpha 2 plus alpha 3 plus so on alpha n. The notation is sigma alpha. That is equal to here minus p1. Try to understand. There minus b by a. The concept here of course minus a1 by a naught is minus p1. Next you can write s2. S2 means sum of two roots, sum of product of two roots taken at a time. Sum of product of two roots taken at a time. Taken at a time. That means sigma alpha 1 alpha 2. So you should write alpha I alpha j, I not equal to j. The notation is alpha I alpha j. That means students alpha 1 alpha 2 plus alpha 2 alpha 3 plus alpha 1 alpha 3 like that alpha 1 alpha 4 like that. That is equal to simply so on. That is equal to the meaning here alpha I alpha j I not equal to j here. Why you are writing I not equal to j means alpha 1 is not there. Alpha to alpha 2 not there. Alpha 3 not there. Whenever you are writing alpha 1 it becomes alpha 1 square. Whenever you are writing alpha 2 it becomes alpha 2 square. I am not going to discuss about to calculate the alpha 1 square. Alpha beta like that. If you are calculating 3 roots alpha beta plus alpha gamma plus beta gamma like that. So if you are taking 2 roots, it becomes next here minus b1 is there. No, the series will become alternate. It is b2 next. S3 means sum of product of roots taken 3 at a time. In the similar way, we can follow proceeding further. S3 sum of product of roots taken 3 at a time. That means sigma alpha 1 alpha 2 alpha. So let us write alpha I alpha j alpha k, where I not equal to j not equal to k. I not equal to j not equal to k. I less than j like that, so we can see 1 less than equal to I less than j less than m. 1 less than I less than j less than k less than m. Like this. 1 less than I less than j less than k less than m. So the value should be followed like this. Greater than 1 and less than. Here 1 less than I less than j less than m. It is, we can notate as minus p3. I think you understood now. First of all minus p1, next to p2, next to minus p3, next to p4, like this. Plus minus will be alternate. So at last Sn. Sn means of course it is nothing but product of roots. It is nothing but the product of roots. That is equal to, that means no need to taken all roots at a time. Taken n roots, product of roots, taken n roots at a time. Taken n roots at a time. Alpha 1, alpha 2, alpha 3, so on, alpha n. That is equal to, you can write minus 1 whole power n of pn. At last we cannot decide whether it is plus or minus. If it is quadratic equation it is plus, if it is cubic equation it is minus, if it is biquadratic equation it is plus, if it is 5th degree minus, if it is 6th degree plus, like that. So we cannot decide the last value, that is simply I put minus 1 whole power n of pn. The minus depends upon the n. If it is even it becomes plus, and if it is odd it becomes minus. Okay, now let us discuss about, just I want to give some examples depends upon the relation between coefficients and roots, and later some formulas we can discuss. Then we can go through for sums. First one, example. The theory only. If f of x is equal to quadratic equation, ax square plus bx plus c is equal to 0. The process is alpha plus beta is equal to minus b to a comma alpha beta is equal to c by a. Depends upon this one. Second one, if f of x is a cubic polynomial, f of x is a cubic polynomial, that is general notation I want to discuss it is that x cube plus p1 x square plus p2 x plus p3 equal to 0. This is general notation. S1, that is alpha plus, I mean if alpha comma beta comma gamma are roots of this cubic equation, let this one of 1, alpha plus beta plus gamma, that is equal to, here alpha plus beta sum of roots. Here S1 means sum of roots taken 1 at a time. You can write minus P1. It is useful formula. Next S2. S2 means taken 2 at a time, alpha, beta, take with alpha, gamma. That's all, there is no other rule, no need to write. Next, you start with beta. Beta alpha don't write because already used it. So, beta gamma you write. It is P2, minus plus minus. The coefficient you write. Next, S3. S3 means the product of simply alpha, beta, gamma. That's all. Whenever 3 roots are there, the process will be for 3, S1, S2, S3. Whenever 4 roots are there, the process for 4, S1, S2, S3, S4, like that. Whenever 2 roots are there, the process for only 1 and 2. Here, alpha, beta, gamma becomes minus P3. Keep aside. Now, another example I want to discuss with you for biquadratic equation. For biquadratic equation. Third one, if f of x is polynomial of f of x is a polynomial of degree n, degree 4 you can take, polynomial of degree 4, then I am writing now x power 4 plus p1 x cube, x power 4 plus p1 x cube plus p2 x square. General notation p1, p2, p3, p2 x square. Next, p3x plus p4 is equal to 0. Depends upon these calculation in objective. Only for MSET we are having Newton formula and Descartes formula, 2 formula are there, which is apart from IP. So that is we need to discuss about the P1, P2, P3 method. Now here S1 means here there are 4 roots. So you can write alpha plus beta plus gamma plus delta. This is delta. Alpha plus beta plus gamma plus delta. If here alpha, beta, gamma, delta are roots. Alpha, beta, gamma, delta are roots of this equation. So alpha plus beta plus gamma plus delta is the sum of roots here minus P1. And next S2. S2 means students taken 2 roots, product of 2 roots taken at a time. So you can start with alpha, beta. The notation I am writing alpha, beta. So whatever the numbers are there, the numbers you should count with product with alpha. So alpha, beta plus alpha, gamma plus alpha, delta. That's all completed. Next is same question. You start with beta. Beta alpha already had written. Don't write. 1 second. Beta with gamma. Beta gamma plus beta delta. That's all. Stop. Next you start with the gamma. Gamma alpha already had written. Don't write. Gamma delta. Gamma beta already had written. Gamma delta is not written. That is why you write gamma delta. Total 6 terms should be there. 6 terms will be there. 1, 2, 3, 4, 5, 6. That's all. So the S2 becomes here P2. The process is same, negative, positive, negative. Now S3. S3 is equal to here. S3 means take 3 roots at a time. Product of 3 roots. So alpha, beta, gamma. Next, with alpha, beta you can understand alpha, beta, delta. Alpha, beta, gamma, alpha, beta, delta over. Now you start with the beta. So whenever you are starting beta, alpha, gamma already you have written. Don't write. Beta with gamma, you write beta, gamma, delta. And another thing is there. Beta, gamma, alpha. Beta, gamma, alpha, you have written. Don't write. Now that's all. Beta, gamma, delta completed. You start with gamma. Gamma, delta, alpha. Gamma, delta, alpha. Okay, now you can write gamma, delta, alpha. Alpha, gamma, delta. So maybe here only we should start alpha, beta, gamma, alpha, beta, delta, alpha, gamma, delta. It is better to write alpha, gamma, delta here only. Plus beta, gamma, delta. 4 terms should be there. Now it is minus P3. Later S4. S4 is equal to the formula product of roots, of course. The meaning is alpha, beta, gamma, delta, that is equal to P4. Now minus plus minus plus. This is the process and this is the way to follow the relation between coefficients and roots. This is most important. Of course, you can understand this method. Depends upon this one. We can read, we can construct some more formula. alpha plus beta plus gamma whole square like that. I am going to be write now formula. Alpha square plus beta square plus gamma square. Alpha square plus beta square plus gamma square, we are going to face such type of process. You can write alpha plus beta plus gamma whole square minus 2 into alpha beta plus beta gamma plus gamma alpha. For a cubic equation I am writing. For a cubic equation, if we want to find out, if we do questions like this, find alpha square plus beta square plus gamma square. This is the formula a square plus b square plus c square is a plus b whole square minus 2 into a plus b c plus ca. You can understand this one as notation s1 square minus 2s2. So remember this one. Alpha square plus beta square plus gamma square. Alpha square plus beta square plus gamma square notation is s1 square minus 2s2. Next. Say this is the first formula. Alpha cube plus beta cube plus gamma cube. Alpha cube plus beta cube plus gamma cube is equal to, this is the formula alpha plus beta plus gamma, a plus b plus c into a square plus b square plus c square minus a minus bc minus ca plus 3abc. This is an important formula. Alpha square plus beta square plus gamma square minus a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. So this is minus alpha beta minus alpha gamma minus beta gamma plus 3abc formula. So this is 3 into alpha beta gamma. This is the formula. If you are having any doubts, simply you can multiply. I think you have learned the formula in matrices chapter first year itself. Now you can write here, this is alpha plus beta plus gamma into, using this one alpha square plus beta square plus gamma square, you can write alpha plus beta plus gamma whole square minus 2 of alpha beta plus beta gamma plus gamma alpha minus of taken this one alpha beta plus beta gamma plus gamma alpha plus 3 alpha beta gamma, that is equal to, now I want to discuss with you that this is s1 into this is s1 square minus, this is 2 into alpha beta plus beta gamma plus gamma alpha minus of alpha beta plus beta gamma plus gamma alpha. You can understand minus 3. This is minus 3s2 plus 3s3. That is equal to, therefore I am going to write now alpha cube plus beta cube plus gamma cube. For simply I am writing for a cubic equation the relations I am writing. For a cubic equation these are the relations. Alpha cube plus beta cube plus gamma cube is equal to s1 cube, you can write s1 cube minus 3s1 s2, s1 cube minus 3s1 s2 plus 3s3. This is the formula. Until here only it is useful, no need to calculate alpha power 4 plus beta power 4 plus gamma power 4. It is for mset only, that is Newton formula, mc later. This is alpha cube plus beta cube plus gamma cube, we got this formula. Now alpha square beta plus beta square gamma for biquadratic equation. For biquadratic or this one, let us going to write alpha square beta. We can write this one as sigma alpha square beta plus sigma alpha beta square, like this. You can understand this one alpha square beta plus, the total 3 roots are there. For cubic equation I am going to discuss with you. Alpha square beta plus beta square gamma. So cyclic expression this is called. Put beta square plus, here you can write gamma square alpha. Alpha square beta plus beta square gamma plus gamma square alpha. This is a sigma. Next this sigma you take alpha beta square. Next one beta gamma square. Next one gamma beta square. Gamma beta square. So now you can understand alpha square beta. Alpha beta square take common here. Alpha square beta plus alpha beta square. Put a bracket here. In the similar way, you can write beta square gamma plus beta gamma square. In the similar way, you can write gamma alpha square plus gamma square alpha. Gamma square alpha and gamma alpha square also should be there. Alpha square beta, beta square gamma, gamma square alpha, alpha beta square, beta gamma square, gamma alpha square, not beta square. Gamma alpha square. A bracket here for a cubic equation. For a cubic equation, x cube plus p1x square plus p2x3 plus p3 equal to 0. Here I am writing alpha plus beta plus gamma is equal to minus p1. Now you can write here alpha plus beta is equal to minus p1 minus gamma, and you can write beta plus gamma is equal to minus p1 minus alpha. Gamma plus alpha is equal to minus p1 minus beta. Depends upon those values. Now you can take common alpha beta here, it becomes beta plus gamma. You can take common beta gamma here, here it becomes beta plus gamma. This is gamma alpha, if you take here it becomes gamma plus alpha. That is equal to, you can write now alpha beta into, instead of beta plus gamma, you can write minus p1 minus alpha plus beta gamma into, you can write minus p1 minus alpha. Next plus gamma alpha into, you can write minus p1 minus beta. Now multiply, it becomes minus p1 alpha beta gamma minus alpha square beta. Minus p1 beta gamma minus alpha beta gamma. This is alpha beta gamma. Here minus p1 alpha beta taken down, it becomes beta plus alpha. So it is p1 minus gamma, p1 minus gamma, minus p1 alpha beta gamma. This is simply alpha beta gamma. Here minus p1 minus beta, this is alpha beta gamma. Here also minus p1 alpha gamma, this is minus alpha beta gamma. That is equal to, you can understand, minus p1 you take common. Minus p1 whenever you are taking common, minus p1 alpha beta, there is no gamma. Whenever you are taking minus p1, within the brackets you can write alpha beta plus beta gamma plus gamma alpha minus 3 alpha beta gamma. This one we can notate. These are the formulae of notations. So that is equal to minus p1 into, you can understand, alpha beta plus beta gamma plus gamma alpha is equal to p2. Next plus minus 3 into alpha beta gamma is equal to p3. That implies write the formula sigma alpha square beta plus sigma alpha beta square for cubic equation. We can write minus p1 means s1 summation of roots, p2 means s2 summation of two roots taken again, minus 3 into p3 means s3 minus p3. So s1 s2 minus p. Minus taken common, here minus alpha beta gamma minus 3 into alpha beta gamma means, here students, minus p3. Alpha beta gamma means minus p3 and alpha beta, so minus p3. So you can write plus 3 minus 3 into plus 3 into minus of alpha. minus beta plus gamma, like this we write. So it becomes minus 3s3. Enough. Minus b3 means s3. So formula is s1s2 minus 3s3, which is useful for IP and object also. Now let us going to discuss about some examples. Students, in our 2A IP textbook, page 101, example 1, 2. He asked to write the relation between the roots and coefficients. He given 1, 2, 3. I am giving homework 5 and the sum of squares. This is homework. Now class work is there, that 4, 5, 6, 7. 4, 5, 6, 7. Let us discuss about next sums later. Now, fourth question. If 1, 2, 3, 4 are roots, if 1, 2, 3, 4 are roots of the biquadratic equation x power 4 plus ax cube plus bx square plus cx plus d equal to 0, then find the values of a, b, c and d. Find the values of a, b, c, d. Whenever he given one root is 1, then leading coefficient is 1. Polynomial equation I am writing. Polynomial equation, whenever he given n roots, you should write x minus alpha and x minus alpha and x minus alpha and so on, x minus alpha n. 4 roots, x minus alpha 1 and x minus alpha 2 and x minus alpha 3 x minus alpha 4. Like that. The required polynomial equation I am writing as x minus 1 into x minus 2 into a bracket here, x minus 3 into x minus 4 is equal to 0. This is a method, another method is there. I discuss now. Yes, let us finish this model. First, let us write this one as a quadratic equation. X square minus 3x plus 2. Next, you can write this one as a quadratic equation. X square minus 7x plus 12. X square minus 7x plus 12 equal to 0. Later multiply in full multiplication method. So x power 4 minus 7x cube plus 12x square minus 3x cube minus of minus plus 3 7 21x square minus this is 36x. Next with 2, this is 2x square minus 2 14 the 2 7 the 14x. Next plus 2 into 12, this is 24 equal to 0. Now you can write later x power 4 minus x cube, that is 10x cube plus 12x square plus 21x square plus 2x square. 12 to 23, 23 and 21 becomes 44. 44x square. Next x terms minus 36 minus 14 becomes minus 50x plus 24 equal to 0. Now comparing this one, that implies you can write compare with given equation. A is equal to minus 10, B is equal to 44, C is equal to minus 50 and D is equal to 24. Simply making the biquadratic equation. A is equal to minus 10, B is equal to 35, we got C is equal to minus 50, B 44x square. I got 21 and 2, 23, 23 and 21. This is x square, and 12x square and 21x square becomes 33x square. 33 plus 2, 35. Maybe here I took it wrong. 35x square. So b is equal to 35. This is a method. While giving the rules, this is a method. Another method, which is easy, you can follow. Second method, required equation. Required equation is x cube minus x not x power 4 minus x1 x cube plus s2 x square minus s3 x plus s4 equal to 0. So s1 means sum of all roots. S1 is equal to sum of all roots 1 plus 2 plus 3 plus 4. S2 means 1 into 2 like this. 1 into 2 plus 1 into 3 plus 1 into 4. Directly you can take 1 into 2 plus 1 into 3 plus 1 into 4 plus 2 into 3 plus 2 into 4. 2 into 3 plus 2 into 4 plus 3 into 4. Later plus 3 into 4 we can take. Total 6 steps. Next S3. S3 means 1 into 2 into 3 plus 2 into 3 into 4 plus 1 into 3 into 4 plus 3 into 4 into 2. That is over. So 3 into 4 into 1, it is also over. 3 into 2 into 4. 3 into 2 into 4, it is also over. 1 into 2 into 3, 1 into 2 into 4. Yeah, 1 into 2 into 4 is this. 1 into 2 into 4. Next, S4 means 1 into 2 into 3 into 4. Now, the equation. Equation you can write x power 4 minus 2, 1, 3, 3, 3, 6, 6 minus 4, it is 10x cubed. Plus this is a 2 plus 3, 6, sorry, 5. 5 plus 4, 9. 9 plus 6, 15. 15 plus 8, 20. 23 plus 12, 35. This is 35x square. This is 6 plus 12, 18. 18 plus 12, 30. 30 plus 8. 35 will get 2 3 is 6 plus 2 into 3 into 4. 6 plus 24, 30. 30 plus 12. 42 plus 50. 50 it is minus. Minus 50x. Next later the term 1 into 2 into 3. The minus plus minus, this is plus. 2 3s are 6, 6 4 24 equal to. Any method you can follow, students. For bicordic one it is possible. If we given 6 roots, then don't follow this method. Simply x minus it, x minus it, x minus it, that method only you follow. Next one, example 5, page number 1 or 2. If ABC are roots, fifth question, page number 102. If A comma B comma C are roots, if A comma B comma C are roots of x cube minus bx square, x cube minus bx square plus qx minus r equal to 0. Find 1 by a square plus 1 by b square plus 1 by c square. 1 by a square plus 1 by b square plus 1 by c square. Now, you can understand here, a plus b plus c is equal to the data I am writing p. So that is S1. S1 is equal to p. S2. So take n product of 2 at a time. AB plus BC plus AC is equal to Q. S3 is equal to ABC is equal to R. Minus of minus becomes plus here. Here also like that. This is of course it is 42Q. Now to find out 1 by A square plus 1 by B square plus 1 by C square. We can take LCM as A square B square C square. Here other than A square you should write B square C square. This is a model. Here C square A square. Here A square B square. Now you can understand students, here BC whole square. BC whole square plus AB whole square plus AC whole square. BC whole square plus AB whole square plus AC whole square by ABC whole square total. This one you can understand, this is a P, this is a Q, this is R like that. If it is otherwise, this is alpha square plus beta square plus gamma square. We can understand alpha plus beta plus gamma whole square minus 2 into alpha beta plus beta gamma plus gamma alpha. You can write using that one. So A square plus B square plus C square cancel, A plus B plus C whole square minus 2 into AB plus BC plus A. So you can understand here BC plus CA plus AB whole square. This is A plus B plus C whole square cancel. Minus 2 into AB, that means BC into AB, plus BC, that means AB into AC, plus AC into BC, whole by ABC whole. Total whole by ABC whole. That is equal to here BC plus CA plus AB whole square, BC plus CA plus CB whole square minus one thing you can understand is B, two terms are there here BAC. Whenever you can take common B, here it becomes A B square AC, here B A square BC, here A square BC. So if we take here B square AC, students, we can take ABC common for all, it is better. ABC, here it is there, ABC is there, here also ABC is there. Then you can write whenever ABC taken common, here it is B, ABC taken common, here it is A, ABC taken common, here it is C, followed by ABC whole square. Now you can understand this 1 by A square plus 1 by B square plus 1 by C square. Yes, this is AB plus BC plus CA S2 whole square minus this is 2 into A plus B plus means S1 into ABC means S3 whole by this is S2 square. So what is S2 here? Now depends upon this one. S2 means here Q square minus 2 into S1 means P into S3 means R whole by S2 square means Q square. Q square minus 2PR by ABC whole square. Not ABC is not S2 square, it is S3. It is S3. So R square. Q square minus 2PR by R square. Now let us discuss the sixth question. Sixth question, find the sum of squares and sum of cubes of roots x cube minus. Find it. Sum of squares, comma, sum of cubes of roots of. Sum of squares, comma, sum of cubes of roots of the equation x cube minus 3x square. X cube minus px square plus qx minus r is equal to 0. X cube minus px square plus qx minus r is equal to 0. If I am writing here, if alpha comma beta comma gamma are roots of given equation, to find out, he is asking that sum of squares and cubes. To find out alpha square plus beta square plus gamma square comma alpha cube plus beta cube plus gamma cube. Before I said the formula that alpha square plus beta square plus gamma square is equal to alpha plus beta plus gamma whole square minus 2 into alpha beta plus beta gamma plus gamma alpha. Here alpha plus beta plus gamma whole square minus 2 into alpha beta plus beta gamma plus gamma alpha. So this is directly you can understand s1 square minus 2s2. So what is s1 square here? P square minus 2s2 means 2 cube. P square minus 2 cube. Next one, a cube alpha cube plus beta cube plus gamma cube. I said the formula alpha plus beta plus gamma a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. So this is alpha square plus beta square plus gamma square minus of minus ab minus bc minus c minus of alpha beta plus beta gamma plus gamma alpha plus 3 alpha beta gamma. I said the formula here s1 into here this one you can understand as alpha plus beta plus gamma. S1 square minus 2s2 and s2 is there, then you can understand s1 square minus 3s3 plus 3s3. So I said already s1 cube minus 3s1s3 plus 3s3, that is equal to s1 means here p cube minus 3 into s1 means p into s3 means r plus 3r. So that is equal to p cube minus 3. This is not simple as this is s2 because this is s2. So 3s1 s2. So p1 into cube here p1 not is p 3p cube plus 3r p cube minus 3p cube p cube minus 3p cube plus 3r. We taken common p and he given an option like this. Next, obtain the cubic equation whose roots are squares of the roots given. Okay students, 7th question let us discuss in next class.